Thank you, Jim, for setting the stage for this session. Great introduction to the subject, putting intelligence back into AI, and what we should not be doing to miss the boat on AI in manufacturing. As Jim stated, we now have 5 distinguished speakers from technology companies that are making a mark in AI applications for manufacturing. Let's begin with Nikunj Mehta, founder and CEO of Falkonry. Go ahead, Nikunj.
Welcome everybody to the SESME annual member event and the Smart Manufacturing Summit 2021. My name is Nikunj Mehta. I'm the founder and CEO of Falkonry. And I want to tell you a little bit about our experiences scaling the adoption of AI in manufacturing. So first of all, let me introduce Falkonry to you because this is the first time I'm meeting with the membership. Even though Falkonry has been in business for almost 9 years and is seen as a leading innovator for industrial AI, you may not be aware of or familiar with us. Our vision is to make industrial operations smart, which is, I know, a key part of the vision of SESME as well. And our mission is to create the finest system for data-driven operational decision-making, which is relevant to both manufacturing as well as defense operations. Specifically, how we do it is that through the use of automated analysis, Falkonry finds important events that you just can't find by any other means. It also explains these discovered events so that it can get people to trust that AI. And then lastly, Falkonry has developed a lot of original intellectual property with dozens of issued and pending patents. So it has taken us a lot of research and development to figure out how we can provide our customers that finest system. It's one of the reasons why Falkonry is recognized by a variety of entities, both public sector as well as private. And Falkonry is seen to be a leading AI maker for the industrial world. Now, we all know that smart manufacturing is not easy. And there are a lot of challenges that we are dealing with. First of all, that our data is in many places still not easily accessible. Secondly, our business evolves quite rapidly. Thirdly, any plant has hundreds of problems that could be improved through the use of data, but that would just take too long for us to solve. And then lastly, but this is actually very important, without experts, there cannot be smart manufacturing. And these experts are extremely busy just keeping the plant running. And so with their limited expert time, it's going to be very challenging to address the needs of smart manufacturing. Now, our approach has been that the smart manufacturing has to be accomplished without hiring new people, and therefore relying more heavily on data that is generated from a variety of sources within the plant. Secondly, we have to be able to do this in a uniform approach so that there is reasoning that can be applied across a plant, across an enterprise if necessary. It has to be automated because we have hundreds of problems to solve. And it has to be able to provide insight into those important behaviors where manufacturing can be made smart. And then lastly, we have to be able to incorporate the expertise in and domain know-how in a way such that our manufacturing keeps improving over time, and that operational feedback and the tacit knowledge of experts can get recorded as part of that automated process. Doesn't mean that experts will not be needed in the future. It's just that they won't be repetitively working on the same problems. Now, here's an example of what we mean by the use of automated analytics for improving manufacturing and making it smart. Here's an example of process variance that arises in pharmaceutical manufacturing, where the dashed line shows a temperature line. And if that temperature is exceeded, then this lot will be unmarketable. It will have to be dumped in garbage. Now, this is a problem that is very difficult to avoid with current methods because an alarm will not prevent that compliance failure. But the pattern of behavior that arises in 2 out of many, many variables, here it's temperature and pressure, are indicative of the compliance failure that is about to arise. So how do we describe and find these precursor patterns? That is what Falkonry's magic is all about. Before we go into the details of how Falkonry does it, identify why we need to do this. So we know that plants are running using both physical systems as well as plant information systems like these. And for decades, we have been running our plants with these, and there are many more plants that will soon be putting these kinds of information systems into their operations. And yet, despite the large number of people who are in operations teams, like in maintenance, process engineering, reliability engineering, and the like, we still have uptime problems. We still have quality issues, and we still have emissions that we have to deal with and energy inefficiency. And on top of all that, the information and knowledge between these people has been very hard to transfer, and it continues today. So this is the environment in which we are trying to make manufacturing smart. The first thing we have to say is that we need to improve the inputs that go into these plant information systems, because a lot of the decisions for how we run the plant will need to be made far better with more precision than we have been able to do in the past. And that's where Falkonry's approach, called operational AI, is primarily focused. Our goal with operational AI is to direct these operations so that we can identify what work might be valuable to carry out that requires human expertise, that requires feet on the ground, so that we are able to achieve greater efficiencies in the production process. And I think this is a relatively stereotypical approach, but I want to make sure that we are all in agreement with this. The second thing is that brain has to build its intelligence from the OT sources of data, such as SCADA and process control systems, in some ways HMIs and alarms, but also the new IoT sensors that are creating even more data. Falkonry has been able to take standard-based approach to connect to these sources of operational technology data, and it has its own intelligence that can be applied to this data from the very beginning of that data availability. Maybe it is prospective from the time this brain gets to work, or maybe it has access to some historical data. So this operational AI has to be intelligent, and it has to be always improving. So what do we mean by that? First of all, it has to on its own find novel events and explain the factors that are the root for those events to arise. It has to announce the events of interest in ways that people can take into account those event root factors, as well as whether or not that would be of interest to them. And then finally, it has to track whether action has been taken on these events. Naturally, we don't always know what action was taken in the plant. We also don't always know whether the actions were beneficial, and we only find out in retrospect. And so it is important that all of this is done in a way such that we can start from operational data and track to the resulting operational data the actions that are happening in the plant. Now, all of this cannot be done without human intelligence. That's where experts come into play. These novel events that are being found by the Falkonry operational AI have to be sometimes tagged, especially when they are new. They have to be mapped to the recommendations that are appropriate to take in those situations. That's not done in an automated manner. That requires human expertise. But once that identification tagging is done, then this operational AI works on its own and relays that information back to people over time. You can almost think of this like your iPhone and photo albums, where the iPhone will identify people in that picture, especially it will organize the same face, even if it doesn't know their names. And then once you give it a name, you can also identify which names matter to you more, and therefore it will track them as favorites. It will provide you some sort of memory lane presentation and remind you about some of those moments from your life. This is basically what AI is understood to be in our day-to-day life, and that's how it should be even in the operational one. Now, all of this sounds perhaps a little too imaginary and maybe futuristic, but this is what Falkonry has been able to accomplish. That's why we are an innovation leader. This is how it works. You have your operational data, pressures, temperatures, currents, voltages, RPMs, and velocities, displacements, etc. Now, you only look at this data when there is a problem and you're trying to understand why did it happen. Well, what we need to be able to do for smart manufacturing is identify and discover these behaviors before they affect our operation. And that is what Falkonry does, is it will discover and distinguish between these conditions without requiring any data scientists or data engineers. And it finds these patterns that are turned into our language, which is events. And these patterns are differentiated from each other. The AI has to figure out which parameters are important, what's the relative weight, how long into the past it has to look, what shapes and waveforms arise. I mean, this is what makes pattern-based approaches very hard to use, but Falkonry makes it automatic and therefore easy. And once it does that, it can surface this as conditions that can be tagged as of interest by being able to give them names, for example. This operational AI, there are many capabilities that get packaged into a simple SaaS app. And it can be deployed everywhere as necessary. As you know, we work with Department of Defense, and they often need these things to be deployed in air-gap environments without any network connectivity. So this combination of a simple SaaS application combined with this ability to deploy anywhere means that it is highly suitable to manufacturing. In fact, Falkonry has been applied in a lot of different environments for improvement of reliability, for compliance, as well as for mission readiness. And it is material that Falkonry is usable both in manufacturing and in defense because it gives everybody greater confidence in the long-term viability of this approach. Here's an example of where Falkonry has been applied at scale. You can see how in steel making, hundreds of digital twins have been created and deployed within a couple of years. And this is the power of AI, that it can actually help you achieve scale. I'm not saying that we should not be doing any machine learning of specific issues, but we should be trying to do this at scale. And that is what is going to matter for our success in smart manufacturing. With that, I want to thank you for the opportunity to speak with you all. My name is Nikunj Mehta. You can, of course, reach me, but I'll be around to answer questions. Thank you very much.